I know everybody's tired of me by now, but I'm going to sit on a different chair this time, so it's going to be a bit of a fresh visual. Thank you for being here. I would like to start off with building on top of what Nina was talking about and asking you, Tālis and Hendrik, to kind of add your perspective as to how we can improve the public perception of biotech. So there's been a lot of talk around today about this. It seems to be one of the crucial things, both for funding and for regulation and for, like, talent and other things. So what would be your take on this?
I would say in the past we tried a lot to convince people with scientific facts, and to some extent that does work, but but only to a certain degree. And I would say that we need some additional push, or in the past it was framed as champions of biotechnology, so someone to look up to. But I think we need some pull factors in contrast to only push factors. So at the moment, I think a lot of biotech is problem-solving oriented. So we have problem X, we solve it with biotechnology, and this is more like a push towards it than a pull. And I think to some extent you need products or services or companies that serve as a role model and that pull people towards a service. I mean, this can mean different things. This can mean that the product is more sustainable, and this is something that you value, and therefore you would go for that product instead of another. It could also mean that the product is just superior in the way it's made up. I mean, we just heard about spider silk, so it's a material with cool properties. As soon as products like this hit the market and you have some sort of advantage by wearing them or like certain features, I think this is something that will pull people towards this naturally rather than just being a push towards it.
So build cool stuff.
Yeah.
Thank you. Tālis?
Yeah, I would agree that we need to communicate biotechnology, bioengineering in different ways. And I think to make it more interesting for the new generation, ecosystem building is important. You need leaders, as I think also actually your foundation is playing a certain role in Latvia, how we build it. But as we talk about interest for students, I can share a bit of our experience. When we decided to start a new program in biotechnology, bioengineering, we tried to approach students indeed through this idea that biotechnology is about building, creating new things, right? So it's like engineering, but just to use more biology, like cells and different type of materials. So that's why we combined skills from two universities, Latvian University and Riga Technical University. And I would say, without too much of advertisement, in the first call we had 250 students applying for this. Actually they had to pay, it wasn't free then, so it has created interest because they realized that they like biology, but they want to make sense out of it. So, and by showing that you have a kind of fundamental research there, but also engineering part, they make them tick, and there's still a great interest about it.
I can also add that some of those students, are doing iGEM here in Riga, and the first thing they did is do TikTok videos. So apparently that's working definitely. Thank you. Taking from there, it's all about the talent. So it's all about what kind of people are doing this. So how do you think? What other ways can we use to attract the best talent, not only necessarily at the school level, but also beyond that and later than that, to biotechnology and synthetic biology, to make sure that we have the best people working to solve the problems and build cool products?
Well, I mean, we have to build awareness. I mean, it's easy when you're inside the biotech bubble, you kind of think that everybody knows what biotech is, but I explain every time I meet relatives or something, I have to start from scratch and I again explain what biotechnology is. So I think we take it for granted that people know, and I work a lot with the university, Aalto University and VTT, and I see the silos between fields of science. So in Finland, we're all about the forest industry, so everybody's doing chemical engineering of forest-based products, and these people have no idea what biotechnology is, even though they are in the same university, maybe even in the same building. So I think awareness is like that's the most fundamental thing. So if nobody knows what biotechnology is, and I would claim that scientists, material engineers from other fields don't know what the possibilities are in biotech. And so that's.
Thank you. You have anything to add as well?
Right. I think there are a few things from my side. I think that still you need to make this, when you talk about education system, to make it interesting. And so which worked pretty well for us, we built about this challenging project. I mean, going to space, build something where you can survive in closed system, using materials from the forest to create something eatable, things like that, using biology, just to make it more resonate more for youngsters. And so the education system in this way also changing. Of course, you need to have a very strong, basis. Of course, you need to know actually in our program, you need to know very deeply math, informatics. You have to, of course, molecular biology, genetics. But then you have to make it also around building things and solving some global problems. Which I think it resonates for students. And second, I think because in many countries, we're still talking about creating new industries. You said, what are you going to do when you finish, right? And when maybe the industry is not there or it's not very well presented, then of course the whole creation of a startup community, how to build new companies, this is very important because then by building these small startups, you create an industry in general, and you create jobs for the graduates of university.
So basically, to attract the best people, we need to give them the most interesting problems to solve.
Yeah.
All right. Thank you. You mentioned startups. I wanted to also dwell on that a little bit. How do you think can we improve our efforts in both creating and also supporting and possibly even attracting world-class biotechnology startups? And I'm not saying it about one specific country, but maybe even Europe as a whole, because there's still a race. I mean, we cannot avoid the fact that some regions are a bit ahead, some are a bit behind. And if you ask people, they will mostly say that Europe is not ahead in this race yet, but it could be. There is a lot of potential, so how do we kind of better realize that potential?
I think we heard a lot about this today already, or it was mentioned quite a lot of times that we could use something resembling the Inflation Reduction Act the US implemented. So I think a lot of big industry is currently leaving Europe, and therefore we should try to focus more on the small and medium enterprises and give them a better basis to grow. This is probably, or this is for that we need support from legislation makers, obviously, but also a change in perspective that we just talked about, like in the push towards it and the push from academic research into the startup field itself. I think this change is happening at the moment. So in the past, the academic career seemed to be quite unidirectional from bachelor student to postdoc and then maybe try to get a junior professorship. But I think a lot of more people are actually thinking about starting a startup right now. I think it's just necessarily to foster that more and help them more to go from the initial to the intermediate stage.
Mm-hmm.
Yeah, I think that that biotech is of course deep tech, more or less the same as you talk about technologies. Before they really get ready, it takes time. So this is the first we need to realize. This is not
Right.
IT or fintech kind of startup. So it takes maybe 10 years before you really get things into the market. And the question is how to make it sustainable. I mean, during 10 years, someone is taking a lot of risks all the time, as you know. So how to make this sustainable? I think we have good examples in US. I think close to MIT, they have this famous lab, which is it's a biotech actually incubator. And so what is I think one of the kind of success factors for this is that it's globally open. So it's not just for MIT, students. It's for everyone, and to make it more globally open, because then you can attract more investors. So I think this is something what Latvia should look into, to have it more global. So we have startups coming from also other countries and mingling with our startups. Yeah, but of course, this is not that simple. But I think this is very important to have a sustainable, like long-term programs to support, very early stage startups, and also make it more open globally, so to have more investors coming in.
Thank you. And speaking of sustainability of startups, I think this is exactly the problem that Synbio Powerlabs is trying to solve. So basically helping them cross this chasm or valley of death where you have something that kind of works, but then you need to produce, in tons or thousands of tons of that.
Yeah.
So how do you go from this? It sounds super daunting if you are a startup founder with limited resources.
Exactly. I mean, easy access infrastructure is really crucial. I mean, also in the earlier stage, in Synbio Powerhouse, we founded this biogarage as well, where startups could, for free, use the lab space and use basic equipment. I think that can have such a huge impact, and it's not a very expensive investment when you're in that stage. Then when you go to Powerlabs stage, it is expensive, and hopefully we will not be as expensive as the bigger players. So being accessible to startups, having these proof of concepts in different size reactor, that's really crucial.
For the benefit of the audience, if a startup from outside Finland comes to you and asks, can we do scale up in your facilities, is it possible, or are you only limited to Finland?
No, absolutely. No, we're open for anyone. We are open for business. Our facility will be ready in first quarter of 25, but you can be in contact already now. So if you need to go scaling up to 27,000 liters or anything below, we have the facilities for that.
Thank you.
Yeah.
We're going to go a bit broader now. We're going to go hop on a helicopter and look from above. I wanted to ask you to share your vision of the biotech's impact over the next, let's say, decade. And what would be the things that your specific organizations are doing to kind of contribute to that biotech future?
I think biotech is pretty ambitious with its goal to conquer or replace the petrochemical industry. I mean, I'm all for it, but I think it's an ambitious goal. I think we're tackling about 35 trillion barrels of crude oil a year, so that's a number to let that go through your head. But I would like to see that tackled more. I really hope that we were able to achieve and to fight this. I think a lot of consumer goods that were in the past produced by petrochemical means are going to be produced biochemically, and yeah, I'm really looking forward to that, to give the consumer a sustainable bio alternative to all the products that we currently have. But it's, as I said, still pretty ambitious.
How do we think we try? I mean, we might not get there in 10 years, but how do you think do we maximize our curve of getting there?
Sorry?
How do we maximize our efforts to getting there? To, let's say, the lofty goal is to replace fossil fuel, to phase out fossil fuels completely, right? At some point in the future, we could think about a future where we're not using, you know, brown liquid, which we dig out of the ground anymore, and we're using something else to produce stuff.
I'm sure it was mentioned a few times today, but feedstock is a huge factor in that. So obviously you can say, yeah, we're going to ramp up our fermentation capacity, but this also means that you have to ramp up feedstock production. So I don't have a solution for the problem right here from the get-go, but I think it has a lot to do with how do we in the future feed our microbes, or what's the carbon source that we use in order to produce. I think that's going to be a pretty big factor. And maybe we're gonna have a revolution of some sort, like the gigafactories did for like the car production, that we're going to have something similar for the biofermentation capacity production. But like out of the pocket, I don't have a solution for like how to improve or like how to tackle this problem. But I think those are the capacity, or the fermentation capacity, will play a huge role in that, and also the chassis that you use for your production.
Is it already becoming a concern with the scale-up facilities, or is it not that enough scale to think about that yet? For example, for Synbio Powerlabs, did you have questions as to like where would the feedstock be coming from?
The feedstock was a huge issue. I mean, in our application process, so it was all about the sugar race. So who is going to win the second, third generation sugar race? So what are all the side streams that we haven't thought about? What are the side streams that tweaking the organism, tweaking the way we extract the sugars out of that, whatever waste or side stream it is? I think that's going to be, during the next 10 years, that's going to be one of the biggest things. So it's really, at the end of the day, it's replacing oil with sugar, with carbohydrates. And where do we find those carbohydrates? We have to look to every area of industry that has some organic compound that can be turned into a feedstock.
And there is a cool Finnish scale-up, I would say, called Solar Foods, which are turning this on its head and saying, why don't we design, if we can design almost anything with biology, why don't we make microbes which don't eat sugar, but eat, you know, let's say, emissions, and then turn those emissions into into nutrients or into useful stuff. So apparently there are other pathways,
Sure.
because the spectrum of tools that we have with biology is so large. We can also go different ways of solving the kind of feedstock. What do they eat problem?
Yeah. Well, I think we're probably going to have all kinds of microbes, so hydrogen-eating microbes and sugar and photosynthetic microbes. They're probably all going to be on the plate, but I think we're quite far with the sugar-eating, so that's going to be the first wave anyway.
Might adding on that, I think people that work in the lab know that like the photosynthetic Synbio is pretty, I don't want to say pretty far behind, but it's definitely behind the microbial or the yeast Synbio. So therefore I think it's just a matter of catching up. At the moment we're heavily focused on fermentation that's done with microbes that eat sugar, but in the future we could transition to something that's photosynthetic active and produces its own sugars from light and carbon dioxide. I think in the past, like engineering algae was pretty difficult, especially because they tend to remove everything that you try to put in their genome quite rigorously. And I think there are very good researchers on this task developing methods to circumvent this and to make photosynthetic chassis more available. And if that happens, I think that's something we need to move towards, and that we're on the right track when we focus more on the green Synbio in that regard.
And not only researchers. Every year I go to Paris for the iGEM Grand Jamboree. There are always student teams, super brilliant people, folks working on using algae as production factories. So basically, like living solar farms that can also produce stuff for you, and they eat CO2 basically. So yes. That's like a win-win for everybody.
Yeah, maybe I'm a bit biased because I work with algae, but I think this is something which could be very realistic in the long run solution regarding the climate change as well. In general, I think if you talk about future, I think there's a very good book by former MIT Rector Hockfield, the Age of Living Machines, where she's talking about all the discoveries which lies ahead, using biology because it's more sustainable, it's cheaper. Of course, there are some risks attached, but I think that this age gonna be biology-driven to some extent. I guess maybe a little biased, but regarding what we do, of course, as I mentioned, we started a new program, which seems to be very successful. We have talented students. They are kind of building up on that, and I mean, the iGEM you mentioned, but there are also other competitions where students can check their ability. So, but it's very important not just to work with students, but also, I mean, work with students in academic sense, but also to kind of incentivize them to talk about the future companies. Because in biology, it hasn't been that popular, to be honest. If you study biology, biotechnology, somehow you do not associate it with creating a startup or something. But this is, I think, the opportunity right now, giving all technologies, CRISPR technologies, and the general synthetic biology. It opens a lot of doors. So I think this future would be in bioengineering, biotechnology, and of course the medical, everything related to medicine, right? So this is we want to live longer, and we want to also mimic some of the things that we learn from nature and then use it for ourselves. Actually, there was one interesting project where they use, it's very hard to imagine that this actually is possible. They use aquaporin as a protein for membrane, inserting in the membranes and use it for water filtration. So imagine, so in a bioreactor you grow the aquaporin and then you just insert in the mechanical membrane and then use it for water treatment. So amazing things which could be done. So yeah, looking forward to this.
It's a very inspiring moment where biotechnology is mature enough to be kind of start-upable at scale, but not mature enough to be boring. So we are living in a very interesting time. I have a final question to you, which is what inspires you the most in working with in this field? What inspires you the most about the future of biotech? And what keeps you going maybe sometimes even?
Well, I think it's because at the end of the day, it's all against entropy. It's like the only thing where you are countering entropy. All of other things we are causing entropy in this world, but putting energy into a living organism and creating something complex with that tool, it's so poetic and so beautiful. And I think that's where my hope lies for the future.
I would say synthetic biology in itself is a research field that combines a lot of techniques from other research fields, and I always like the fact that it's not too linear and that it's always like changing, and new tools that are developed in one field can be applied into your field. And so I'm super hyped, like reasonably hyped for the implementation or the possibilities that the current AI developments open up. I mean, probably all of you are aware that AlphaFold 3 just came out. So in that space or in other spaces adjacent to biology, a lot of development is happening as well. And I love how one is bleeding into the other, or like one is taking knowledge from the other. So I'm super interested, or I'm super motivated to see how this all is going to like evolve further, and which is the next field to be incorporated into the biosphere.
Thank you.
I think two things. For me, I inspired by opportunities what we have in front of us. I mean, you, as I mentioned, few examples, but of course you can find many examples where you never thought about how can you really use the biology for human good. So I think this is a huge window of opportunities. First of all, maybe IT somehow is kind of getting its plateau. Of course, artificial intelligence, but I feel that biology is growing. So this is one. And of course, as a scholar and a rector, I'm really inspired by the new talent which we have in our university, and they will make future.
Thank you so much. Thank you. That concludes our last panel. Round of applause, please.
Thank you so much to all the panelists.